This is part two for chapter 4.2 on algorithms. This time it's for subtraction. This is a short video just introducing the standard algorithm for subtraction. And so you can see there's the term right there again, standard algorithm. An algorithm again is a series of steps we use to solve a problem or do some process. And many times that's just with computations. And so in this case here, you have a picture here of what it looks like to do a problem here. 357 minus 123. So I'm going to do that over here. You can recreate that. 357 minus 123. Now to subtract that, remember this can be done with takeaway approach, missing add-in approach, but more than likely what we do, the standard algorithm, what we do is we just do 7 minus 3 is 4, 5 minus 2 is 3, 3 minus 1 is 2. And so then you get your answer. Now, why that works is, again, it comes back to place value. And so it's important to realize that these are how many ones we have, these are how many tens we have, and how many hundreds we have. And so we're just taking away 3 from 7, 2 from 5, 1 from 3. And so what's happening is it kind of looks like this right here. This is what's really being done. What is happening, you're subtracting those values because that's how many we have in that place, right? Because our numbers are positional, and so we're just taking away. Now, an issue arises in the standard algorithm is when we have to what we call borrow, but we don't necessarily like the term borrow, right? That's when we have to, what we call borrow is really what we're doing is we're exchanging one of the place values, the bigger place value, for the smaller one. So if we take a 10, that means we'll break up one of the tens into 10 units. And so we could create another problem. Let's do one real quick just to show you what I mean by that. So let's go with 1, 2, 3, 4, 1, 2, 3 minus, let's go 54, right? So in a problem like that, as an example, I can't take away 4 from 3. And so what happens here is I only have 3's. And so what I need to do is I need to take one of my 10's and then give it here, right? And so then that becomes a 13 because I've taken one of these 10's. And how many 10's are left? 1. Now I have 13 ones, take away 4, and now that's 9. And so now I have one group of 10 left, and with 5 groups of 10, I can't take away 5 groups of 10 from 1. So what I need to do is I need to not borrow, I exchange. This is 100. And so then what happens is now I have 11 groups of 10, take away 5, and so then you end up with 11 take away 5 is 69. So that's that idea. That's that idea we talk about borrowing or exchanging. It's really not a borrow. We're really exchanging or regrouping when we do that process. So keeping that in mind. And that's, again, a standard algorithm. Now, if you want a non-standard algorithm for subtraction, you're not going to see it in the book, but I think you can invent one yourself. Here's one just to introduce to you to see how you think about this. 123 minus 54. And if we want to do kind of an intermediate algorithm, what I think could work, 3 minus 4, it's negative 1, right? And then you say, if we want to look in this way, how could that help us there, right? When we're looking at that, and then you do again, it's not in the book, but I just want to introduce that you could kind of do this, and then you have 20 take away 50, that's negative 30, and then you just have 100 take away 0, so then you have 100. And so if people understand negative numbers, or students understand negative numbers, you can see that the answer would be 69 because that's the negative 31. This becomes negative 31 put together with 100, and you get 69. It's just an alternative. It's not in the book. I just want to introduce that there could be other ways to do this. But students at young grade ages wouldn't do that because they don't know negative numbers yet.